You are standing in the middle of a sentence. Your mouth is wide open. The audience is staring at you in complete, unbroken silence. You know exactly what you want to say. The concept is crystal clear inside your head. The image of the object is vivid and precise. But the specific word for it has completely vanished. It feels like it is hovering right on the tip of your tongue. You can feel its starting letter. You can almost hear its rhythm and number of syllables. But the actual word refuses to cross your lips. Your brain has physically locked you out of your own memory vault. You panic. You wonder if your memory is starting to fail. You wonder if you are getting burnt out, distracted, or early signs of brain damage. But you are completely wrong. This excruciating mental blackout is not a sign of weakness or illness. It is a universal, incredibly sophisticated feature of human neurology. Scientists have an official name for this exact feeling: the tip of the tongue phenomenon, or TOT. It happens across every culture, every language, and every age group on Earth. But why does a biological supercomputer capable of storing petabytes of information suddenly fail at retrieving a single, simple word? Why does your brain hide words you undeniably know? To understand this mental glitch, you need to look at how your brain builds a word in the first place. When you want to speak, your mind does not just pull a finished word out of a simple filing cabinet. It executes a complex, three-stage assembly line across vast neural networks. Stage 1 is the semantic level. This is pure abstract thought. If you want to talk about a large, gray animal with a trunk, your brain instantly activates the concept of an elephant. You see the image, you feel its size, and you understand its meaning. Stage 2 is the lemma level. This is where your brain selects the specific grammatical code for that concept. It assigns whether the word is a noun, a verb, or an adjective, and determines how it fits into your sentence structure. Stage 3 is the phonological level. This is the raw sound blueprint. Your brain retrieves the precise sequence of vowels and consonants, ELEP8ANT, and sends signals to your vocal cords, lips, and tongue to produce the physical sounds. Under normal conditions, this entire three-stage process takes less than 200 milliseconds. It is so fast and effortless that you do not even realize it is happening. But during a tip-of-the-tongue state, something breaks down between stage 2 and stage 3. You have successfully unlocked the semantic concept. You have selected the correct grammatical lemma. But the bridge to the phonological sound files has suddenly collapsed. You are holding the key, standing in front of the door, but the lock is physically jammed. Scientists led by Dr. Corinne Humphreys made a shocking discovery about what actually happens inside your neural pathways during this moment. Your brain is not sitting idle, quietly searching for the missing sound. It is actively sabotaging itself. When you try to recall a target word, nearby words with similar sounds or meanings are also activated in your neural network. If you are trying to remember the word pantheon, words like pantherium, panther, or Parthenon light up inside your brain. Normally, your brain suppresses these incorrect competitors instantly. But in a TOT state, one of these incorrect words accidentally gets too much electrical energy. It acts like a persistent mental intruder. This intruder blocks the neural pathway to the real word. And every single second you sit there, straining and desperately trying to force the word out, you are making the problem significantly worse. Why? Because human brains are plastic. They learn through repetition. When you spend 30 agonizing seconds struggling on the tip of your tongue, your brain does not learn the correct word. It learns the act of struggling itself. You are actively building and strengthening a faulty neural shortcut that connects the concept to a dead end. Dr. Humphreys discovered that if you spend a long time struggling to find a blocked word, you are drastically more likely to experience the exact same tip-of-the-tongue state on that identical word in the future. You are literally training your brain to forget it. But why would evolution leave such a frustrating design flaw in human speech? The answer lies in the incredible trade-off our ancestors made for complex language. An average adult knows between 20,000 and 30,000 words. To make speech fast and fluid, your brain prioritizes speed over absolute accuracy. It stores sounds and meanings in separate neural compartments, so it can reuse building blocks efficiently. If every single word was stored as an isolated, unchangeable lump, your speech would be painfully slow and robotic. Your brain willingly accepts rare retrieval glitches as the small price for lightning-fast human communication. But there is another, even darker reason your brain deliberately hides words from you: cognitive fatigue and emotional stress. When you are anxious, embarrassed, or performing under high pressure, your body floods your bloodstream with cortisol and adrenaline. These stress hormones act like heavy signal jammers in your prefrontal cortex. Your prefrontal cortex is the executive command center responsible for focus, search, and recall. Under the influence of stress, the delicate electrical bridges connecting your lemma to your phonological sound files simply shut down. Your brain redirects all its resources away from complex vocabulary search and throws them directly into survival mechanisms. Your evolutionary biology does not care about you sounding articulate in a business meeting or a school presentation. It cares about keeping you safe from perceived threats. So when you feel the pressure rising, your brain intentionally locks down complex language retrieval. What about sleep deprivation? When you lack sleep, the neural connections in your temporal lobe where sound representations are stored become weak and inefficient. The electrical signal simply decays before it can reach your vocal muscles. You end up muttering, "You know, that thing, the thingy," while your brain desperately tries to reboot its search engine. But here is the most fascinating part of the tip of the tongue state. It reveals that your brain possesses a strange, almost magical form of self-awareness called metacognition. Metacognition is knowing about knowing. When a TOT state hits, you do not just draw a blank. You consciously know that you know the word. You can accurately state that it starts with a P. You can confidently guess that it has 3 syllables. You can feel its weight in your memory. How can you know so much about a word without actually knowing the word itself? Because your brain's monitoring system operates independently from its retrieval system. Your monitoring network feels the strong residual electrical trace left by the word, even when the sound files cannot be accessed. It is your brain's way of telling you, keep quiet for a second, the file is in here somewhere. So, what should you actually do the next time a critical word vanishes right when you need it most? The worst thing you can possibly do is sit there, frowning, straining your eyes, and trying to force it. Remember Dr. Humphrey's discovery. Straining only strengthens the neural barrier and cements the mistake. Instead, you must use a cognitive trick called strategic distraction. The moment you realize you are stuck on the tip of your tongue, completely drop the search. Look away, move on to a different sentence, or change the subject entirely. When you consciously abandon the hunt, your prefrontal cortex stops firing heavy spotlight beams down the blocked neural path. This relieves the electrical pressure. It allows the incorrect competing words to cool down and fade away. Meanwhile, your background subconscious processing continues quietly in the back of your mind. It bypasses the jammed highway and takes a quiet side road to the sound file. And 10 minutes later, while you are quietly pouring a glass of water or driving your car, the word suddenly pops into your head completely unprompted. Parthenon. You burst out loud, scaring anyone sitting near you. That is your subconscious delivering the retrieved payload after the neural traffic cleared. Another powerful technique used by linguists is called semantic pivoting. If the word architect is stuck, do not keep repeating building guy. Pivot to unrelated aspects. Describe what they wear. Picture the blueprints, or imagine the sound of pencil on paper. By approaching the target node from entirely new neural angles, you ignite fresh electrical pathways that easily jump over the broken bridge. As you get older, TOT states happen more frequently. In your 20s, you might experience 1 or 2 tip-of-the-tongue moments a week. By your 60s, it can happen multiple times a day. People often panic, viewing this as the first terrifying step toward cognitive decline, or dementia. But extensive neurological studies show that age-related tau T states are usually not caused by losing brain cells. They are caused by the sheer volume of your internal library. Over decades of living, learning, and reading, your brain accumulates an immense archive of words, names, places, and memories. The library is not decaying. It is just packed to the absolute ceiling. Finding one specific, rarely used word among 30,000 candidates in an aging, highly experienced brain simply takes slightly more search time. It is a badge of a rich, well-stored mind, not a broken system. Modern technology, however, is introducing a brand new variable to this ancient equation: the Google effect, or digital amnesia. In the past, when a word was stuck, you had to wait hours for your subconscious to find it, or ask a friend. Today, the very microsecond a word hesitates, you pull out your smartphone and type the definition into a search bar. Within 3 seconds, the answer is glowing on your screen. It feels helpful, fast, and efficient. But neuroscientists warn that instant searching acts like an intellectual crutch. By instantly searching for the answer, you rob your brain of the opportunity to let its subconscious repair the broken neural bridge naturally. You prevent your monitoring system from exercising its metacognitive muscle. Over time, relying on immediate digital rescue makes your natural word retrieval networks lazier and more prone to frequent blackouts. You are outsourcing your internal dictionary to the cloud, so the next time your mouth freezes in the middle of a sentence, the next time a familiar name or word completely vanishes into thin air, do not panic. Do not beat yourself up. Do not immediately reach into your pocket to search for it online. Smile and recognize what is actually happening inside your head. Your brilliant, complex biological supercomputer is simply clearing traffic, suppressing intruder signals, and rerouting neural bridges. Take a deep breath, pivot your thoughts, let your subconscious work its silent magic, and let the hidden word find its own way back to you. You are standing in the middle of a sentence. Your mouth is wide open. The audience is staring at you in complete silence. And now you know exactly what your brain is doing behind the scenes.